Hi, Math 30s. This question is from your note package in lesson 5. So when we did lesson 5, I said we will skip this question and come back to it. Basically, what we're doing in this question is we're going to be fully factoring this polynomial expression, and then we're going to be solving it. I'm going to talk about the difference between factoring and solving. What happens is up to this point, everything that you factored had a leading coefficient of 1. So all of the examples up to this point, the a value, which is our leading coefficient, has been 1. And this question is going to show you what you would do if you had a leading coefficient that was any number other than 1. So the first thing that we're going to do in order to solve this is we are going to list the potential zeros of the polynomial, and we've done this several times. So you take that constant term, and the potential zeros of this polynomial would be the factors of 2. So the factors of 2 are plus or minus 1 and plus or minus 2. So there's 4 potential zeros for this polynomial. Instead of checking each of these 4 potential zeros, the easiest way to figure out which of these potential zeros are actually factors is to plug this polynomial expression into your calculator in Y1. So I want everybody to take out their calculators, go to Y1, and let's plug that in. So if I go to my calculator here, in Y1, I have the polynomial function punched in, so 3x cubed minus 4x squared minus 5x plus 2. Then I always look at the table of values, so second function table. And this polynomial, I could right away see 2 of my zeros. So one of my zeros is going to be at -1, and the other 0, or x-intercept, is going to be at 2. So I'm just going to write that down. And we'll say, okay, so we know that p of -1 is equal to 0. Therefore, I know that x plus 1 is a factor. So that's one of my factors. And the other one, I believe, was 2. I just need to double check that it was in fact 2. Let me see. Yes. So p of 2 is equal to 0. So x is equal to 2 is going to be one of the x-intercept, or one of the zeros. So let's write that down. So p of 2 is equal to 0. Therefore, a second factor that I know is going to be x minus 2. So I've just gotten 2 out of my 2 factors I know for sure. Okay, so from here, we're going to use synthetic division. So pick one of your zeros, and we're going to synthetically divide. So I'm just going to take, I'll take this first one, -1. So I'm going to take the 0 of -1. And I'm going to write my coefficients. So 3, -4, -5, and 2. Drop that first number and then carry out your multiplication. So 3 times -1 is -3. With synthetic division, we add. -4 plus -3 is -7. Carry out your multiplication. -7 times -1 is 7. Add to get 2, multiply to get -2, and add to get 0. So this is my remainder, which is correct, right? So the remainder is 0. So that means that this is a 0, and x plus 1 is the factor. This is my quotient, which is q of x. So my quotient is 3x squared. Remember, if this is a third degree, your quotient is going to be a second degree. So 3x squared minus 7x plus 2. So what I know so far is I've factored my polynomial down to p of x is equal to the divisor, and the divisor gives me the factor right here of x plus 1 times my quotient, And then normally we would put plus the remainder, but I don't need to add plus 0. Okay, they want this fully factored. So as it stands, it is not yet fully factored. So what I need to do is, I know, for example, that x minus 2 is a factor, right? And I could use synthetic division, or I could say from this, because it's an x squared, I could do PSA2 or decomposition, right? So let's factor this guy. So PSA, and we're looking for what gives us the product of our A value times our constant. So we're looking for a product of 6 and a sum of -7. So the two numbers that multiply to 6 and add to -7 are -6 and -1. From here, I'm going to factor this by decomposition. So to review factoring by decomposition, you break down your -7x and you say, what two numbers, how could you break down -7x? -6x minus 1x, right? So you use your answer. That will give you -7x. Bring down your +2 and bring down your 3x squared. Whenever you have a PSA2 question or a decomposition question, you will always get 4 terms. You take those 4 terms, you split them in half, and you group factor. So ask yourself what comes out of a 3x squared and a 6x, and that would be a 3x. Um, 3 divided by 3 is 1, x squared divided by x is x minus 2. Then on your right-hand side, what you could take out of a 1 and a 2 is a 1. And you must always tell me your sign, so it's a -1. And then you'll have -1 divided by -1 is 1x. 2 divided by -1 is -2. If you did your decomposition factoring correctly, these two must match. So one of my factors is x minus 2. The other factor is 3x minus 1. Then we know that my polynomial also had this factor, x plus 1. So let's write down that factor. And this is your polynomial completely factored. So they want it in factored form. So we must say p of x is equal to, and this would be your answer in factored form. Just to double check, let's go back up to the top. We knew that x plus 1 was a factor. We knew that x minus 2 is a factor. So x plus 1, x minus 2. And I'm going to show you quickly how I know that this is a factor. So how I know that this one was a factor, if I said what would that 0 or that x-intercept be, 3x minus 1 is equal to 0. If we were to solve for x, I would get 3x is equal to 1, divide both sides by 3, and x is equal to 1/3. So I'm going to argue that one of my x-intercepts, or my zeros, is 1/3. How I could prove that is if I type in p of 1/3, and if I get a 0 here, it's going to be a factor. So you could check this in one of two ways. You could take 1/3, and you could go back to your original polynomial. Every time you see an x, you could put in a 1/3. Or, because I have this entered into my calculator, I could take my calculator out. Let's look at the graph. So there's 3 zeros on this graph. I know that that 0 is 2. I know that that 0 is -1. Let's check that this is 1/3. So we could do it in two different ways. I could either go second function, calculate a 0, and I want to check this 0. So I'm going to go left of the 0. I'm going to go right of the 0. That number is 1/3. The other way that you could check this is second function, calculate. I'm going to check a value, and I want to check what is when x is 1 divided by 3. When x is 1/3, y is 0. So my polynomial, p of 1/3, is equal to 0. So that is, in fact, 0. Okay, you need to be able to understand for the exam, so this is going to be a long answer question, and you need to understand the difference between factoring and solving. If the question says factor the following polynomial, so this one said fully factor, your answer for fully factoring would be this answer here. If it says solve, what you need to then do, once the question says solve, is you need to, solving means we need to find the zeros. So you're going to take your fully factored equation and you're going to put 0 is equal to x plus 1, x minus 2, 3x minus 1. You must write this when you're solving. So when you're solving, you're going to be equating each factor equal to 0. Now, I need to see this step, and then from here, you could tell me what all of your x-intercepts are. So this x-intercept or this 0 would be at -1. This x-intercept would be at 2, and this x-intercept would be at 1/3. And this would be your answer for solving. But once again, if you don't have this, if it was a 5-mark question, you would get -1 if you're missing this. Okay? What I want you to do to see if you understand this, these are the questions in your workbook. So it's on page 327, and there's 4 of them. There's 4 polynomials that they ask you to either fully factor or solve, and all of those polynomials have an a value other than 1, so an a value that's not 1, and all of them would involve essentially, you're going to be doing decomposition. Okay, so all of them are going to get you, one of your zeros is going to be not an integral 0. It's not going to be an integer. It's going to be a decimal number or a fraction.